following video cassette is a presentation of Youth Enterprises. Coming up next on Amazing Discovery's home video cassette program, we're going to show you how to become a human calculator. You'll learn addition, subtraction, multiplication, squaring, and more. We'll even teach you a trick to amaze everyone. You'll finally learn how fun and easy math can really be. So sit back, relax, and get ready to learn with the human calculator himself, Scott Flansburgh.
Congratulations on taking your first step to becoming a human calculator. Today in our program, I'll show you guys how to really make math fun, all right? And I'll show you a lot of different ways to get to the right answer. Remember, that's the key today, all right, to get the right answer. Now, to get started, let's get our brains warmed up a little bit. So to start out, could you do some addition for me? Go ahead and stand up. I got to add up a bunch of numbers in my head here. It gets me going, okay? So pick a whole bunch of 3-digit numbers, and I'll try to add them up. And you guys add them up on your calculator, all right? So you give me a number, and then I'll say plus, and then you go back, and we'll just keep doing it, okay? And you guys just keep up on the calculator. Go ahead.
522
plus
697
plus
523
plus
126
and one more.
722.
2,590. Is that right? All right. Okay, very good. Thanks. Let's try some multiplication right here. Could you stand up? Okay. So let's start out with 2-digit numbers. Just give me two-digit numbers, and I'll multiply them in my head, and you guys do it on your calculator. Go ahead.
32
times
75.
That'd be 2,400. Is that right? Let's try another one. Go ahead. Can we pick a 3-digit number times a 2-digit number?
567
times
68.
34,000. Hang on, this is a real hard one. You got me on this one. I think it's 28, 34, 39, 690. How about 38,556? Yeah. Is that right? That was really hard. Okay, let's try some division. Let's see. Give me a division problem. Pick like a 3-digit number and then divide it by a 1-digit number. All right?
Okay, 2 divided by...
Well, the other way around.
Okay, 400 divided by 2.
400 divided by 2 is pretty easy. It's 200. Let's try another one. Go ahead, right here.
Oh, me?
Yeah.
Okay, 658 divided by 9.
That'd be 73.111111. Okay. Now, let's try something a little bit harder. How many of you know what a cube is? All right, now let's try that. Everybody with your calculator, go ahead and clear it. And now, pick a 2-digit number and punch it in. All right, don't tell me what it is. And then hit your multiplication key. And then hit the same 2-digit number again. And hit your multiplication key. And hit the same 2-digit number again. And hit equals. Okay, now what you just did was you cubed a number. You multiplied it times itself 3 times. All right? Now what you got to do is tell me the answer you have on your screen, and I'll try to tell you the number you started with. It's called extracting the cube root. And this is something I'll teach you a little bit later on. Who's got an answer? Anybody? Okay, what did you get?
91,125.
45. All right, let's try another one. Go ahead, what'd you get?
21,952.
That'd be 28?
Yep.
Okay, let's try another one.
Yep.
Who else has one? All right, go ahead.
1,331.
11. That one's an easy one. One more. Let's try one more. Did you get one?
103,823.
47. Okay, now, that's called a cube root. That's real easy. I'll teach you how to do that. Now, everybody with your calculator, this is a little bit different. Everybody clear it. Go to 0. And now I'm going to teach you, well, I'm going to show you how to do a constant. Pick a 3-digit number.
300.
300 in, keep going, some weird number. Any number will do.
Any number?
Yeah.
6,000.
300 and, try 300 and something.
Okay. 390.
399? Okay, everybody go. 399 plus 399 equals. Okay, everybody get 798? Okay, now keep hitting the equals key. The next one would be 1197, 1596, 1995, 2394, 2793, 3192, 3591, 3990, da-da-da-da-da-da. It's real easy to do, okay? Don't worry. Now, what I want to do is go ahead and let's get things started. How many of you think you can do mental math in your head? A lot of like 2- and 3-digit multiplication and stuff like that, all right? Most people don't. So what I'm going to attempt to do is show you how to do that. So the first thing we're going to learn how to do is addition, because that's the easiest thing, all right? Let's start out with a column of numbers, 123, 226, 121, and 214. Now, to add these numbers up in your head, there's a real easy way. Don't we normally start over here on the right side in the ones, and then we carry and add and carry and add, and all of a sudden, surprise, you get this big answer? When I do it in my head, I do it left to right. I start in the hundreds, and I go to the ones, okay? And here's how it works. This 1 right here, doesn't it stand for 100? Okay, and what's this 2 stand for?
200.
So now, we're going to keep a running total in our heads, all right? What's 100 plus 200?
300.
Plus another 100,
400.
plus 200.
600.
Now, you take 600 and we go to the top of the next column, which is the tens. So this 2 stands for 2 tens or 20, correct? So what's 600 plus 20? 620. Plus 20 more? 640. 660 plus 10. So we have 670. Now let's go to the ones. What's 670 plus 3?
673.
Plus 6? 679. 680. And that's the answer, 684. Does everybody see how that works? You still get the same answer, but you don't have to write anything down until you get the whole answer. You're just keeping it in your head. It does 2 things for you. First of all, you had to identify what each number stood for. This is a 4, this is 20. It's called place value. The second thing is estimation. As soon as you did this left side, you knew it was going to be 600 or 700 right away. All right? So it's real good for your estimation skills. Now, who thinks they could probably do this? Okay, come on up. Let's try one, see how you do. Okay, if I gave you 245, 124, 111, and 216. Can you try that?
Yeah.
Go ahead and just talk it out loud to us. See how you do.
Okay.
What-
200.
200,
300.
300,
400. 600.
600. Now let's go to the top of the tens.
640.
Good.
660.
Keep going.
670. 680.
680.
685.
Right.
689.
Mm-hmm.
690. 696.
Does everybody agree with that? 696? That's right. Very good. Thank you. Okay, so does everybody see how easy this is? Okay, but you got to practice. So to practice, take your time and write down a bunch of 2-digit numbers maybe and practice with that first, then do 3-digit, and you can do 4-digit if you want. But what it does is it helps you get used to being able to use this technique, all right? And we're going to use this the rest of the program in our multiplication, everything we learn how to do, you've got to be able to add, all right? So you got to remember how to do this. All right, now, let's try subtraction, all right? But here's my little theory on subtraction. I really don't do that. What I do is a thing called negative addition, all right? Because our minds really don't think in the way of subtraction. Our minds are always adding, and it's just negative addition. So let me give you an example of how I do this, all right? Let's do 456 minus 232. All right, now, again, instead of starting on the right, I start on the left, all right? So what would 400 minus 200 be? 200. And now what's 50 minus 30? So keeping a running total, how much do we have so far? 220. And what's 6 minus 2? So what's the answer to 456 minus 232? 224. All right, does everybody see how we did that? Okay, just keep track of the number, just like an addition, all right? And doesn't it work out a lot easier? Because right away you knew the answer was around 200 something, right? Let's try another one. What's 546 minus 312? But now, let's get somebody up here that thinks they can do it. Right here, come on up. Would you do that? All right, 546 minus 312. Now, what do we do?
You take the 500 and subtract 300 from it. That's
Right, and what do you
200.
get? You got 200 so far.
And then you take the 40, subtract the 10,
And
that's 30. That's
so much do you have so far?
230.
Right.
And then you take the 6, subtract it by 2, and that's 4.
So what's the answer?
It's 234.
Very good, 234. All right. Now, let's see what happens when we have to actually borrow doing subtraction. Let's use 546 minus 227. All right? Now, we got to keep track of the number in our head. So first of all, what's 500 minus 200? 300. And now what's 40 minus 20? 20. So how much do we have so far? 320. But now, here's where you got to flash. Right here, isn't this number bigger than this number? Okay, so we got to borrow, right? So we had 320, but now knock it down to 310. So what's 16 minus 7? So what would be the answer? 319. Very good, okay? Takes a little bit of practice. It's a little bit harder at first, But once you get used to it, it'll help you get the answer real quick, and right away you'll know what the answer is going to be about, okay? A good estimated answer. So practice a lot with that one, okay? Now let's see, who could do this? 542 minus 224. Who thinks they could try that? All right, come on up. You ready?
Yeah.
All right, what do we do first?
500 minus 200 equals 300.
300, and now what?
Which is 300, 4, and 40 is 4. 4 equals 40, and 2 equals 20. So 40 minus 20 equals 20.
20, so how much do you have so far?
320.
So you got 320. Now what do you see?
2 over 4.
Right, this is bigger, right? So we're going to have to borrow from that 320. How much do you have left?
You have 310.
310, and now what's 12 minus 4?
318.
Wow, okay, that was the answer, right? Way to go. Wasn't he good? All right. Now, let's try multiplication. Let's see. Who looks like they're really good at... Well, okay, what I'll do is I'll show you how to do it first. Then you guys pick if you want to try this, all right? First of all, 12 times 14. It's a real easy problem. But now, don't we normally go 2 times 4 is 8, and 1 times 4 is 4, and drop a 0 and all that? Well, there's a couple of shortcuts I want to show you. The first one is the technique is called right to left cross multiplication. And here's how it works. You go 2 times 4, and what do you get? 8. You write that down. Now, to get the second digit in the answer, all you have to do is you multiply crosswise both ways and add it together. What's 2 times 1? 2. And what's 4 times 1? 4. So what's 2 plus 4? 6. That's the second digit in the answer. Now to get the other digit in the answer, this number here, all you have to do is multiply these two numbers together. What's 1 times 1? 1. So the answer to 12 times 14 is 168. All right, does everybody see how that works? All right, let's try another one. How about 24 times 12? Okay, what do we do first? 4 times 2, what do you get? 8. 8. And now we got to cross multiply and add. That's what it's called. So what's 4 times 1? 4. And 2 times 2? 4. So what's 4 plus 4? 8. Very good. And now the left side, what's 2 times 1? 2. So the answer is 288. Does everybody see how that work? It's pretty easy. All right, come on up. Let's see how she does. Okay, let's use a little bit harder problem, and we're going to carry also, okay? So we'll learn how to carry in this example. 24 times 13. What's the first step? Go ahead.
3 times 4.
3 times 4, what do you get?
12.
12. So what you do is you write down the 2. Now what you do is you have to carry the remainder to the next step. So we have a 1 to carry, right? Mm-hmm. Now what's the next step?
Then you cross multiply.
Cross multiply. What do you get each way?
4 and 6.
4 and 6. What's 4 plus 6?
10.
And now we add the 1 in. What do you get? 11, right? 10 and 1. That's okay. Now, so we write down the 1 and we have to carry 1 again, all right? Now what do we do?
Then you multiply these times.
Right, what's 2 times 1?
2.
And add the 1 we carried.
3.
So the answer is 312. Okay? See how let's try another one. What's 32 times 14? All right, go ahead. What do we do first?
4 times 2.
And you get?
8.
Okay, now what?
Then you cross multiply.
Cross multiply. Go ahead, tell us what you do.
4 times 3 is 12. And 1 times 2 is 2. So
Right.
14.
Right, what do I do?
Write the 4 and carry the 1.
Carry 1, and now what?
Then you multiply this times that.
Right, what do you get?
3
And add the 1.
is 4.
So the answer is 448. Very good. Is that pretty easy to do? All right, thank you very much. You got to practice a little bit though, okay? It's a real easy technique. When it looks neat because all you do is write down the answer, okay? Now that's only one way. It's called right to left cross multiplication. But I'm going to show you another way that's called left to right cross multiplication. So let's go back to the same example we used. We did 14 times 12 first. Now, here's how left to right cross multiplication works. We're going to start over here instead of over here. This 1 right there, what does this stand for? 110 or 10, right? And what's this stand for? 10, and this is 2 and 4. So think of it as 4 separate numbers, okay? 10, 10, 2, and 4. Left to right cross multiplication. We're going to do that running total in our head thing again, all right? First thing we do is multiply these two together. What's 10 times 10? 100. That's our base number. Remember, this is your base number, okay? Now we're going to multiply across. What's 10 times 2? 20. Now add it to our base number of 100. What do you get? So our new base number is 120, right? Now we cross multiply the other way. What's 10 times 4? What's our base number? 160 now. 120 and 40 is 160. And now we're going to multiply the two numbers on the right. What's 4 times 2? And add it to our base number of 160. So the answer is 168. All right? All you do is keep track of that one number in your head again, and you just keep multiplying across. So let's try a little bit bigger. 24 times 13. That's the other one we did, right? All right. This 2 right here, what does this stand for? 20, 10, 3, and 4. So first, what's 20 times 10? 200. Now we cross multiply. What's 20 times 3? Add it to our 200. 260. Now what's 10 times 4? Add that to our 260 and you get 300. Very good. And now 4 times 3 is? So add it to 300. So the answer is 312. All right? That's called left to right cross multiplication. It's a little bit more involved, but it's really pretty easy if you get used to the numbers, okay? Now, what I want to show you now is something that's really neat because people have usually never seen this. It's called complementary multiplication, all right? Let's say you have two real big numbers like 96 times 94. Now that's a lot of multiplication. Usually you have to do all the regular stuff. But there's a real easy shortcut. It's a 3-step called complementary multiplication. Here's how it works. How far is 96 from 100? 4. So we write a 4 down. And now how far is 94 from 100?
6.
So we put a 6 down. Now here's how you get the answer to 96 times 94. You subtract diagonally first. What's 96 minus 6? 90. You write down the 90 right here. Okay? Now, these two numbers we wrote over here on the right-hand side, what's 4 times 6? 24. So the answer is 9,024. Is that pretty easy? Okay, that's called complementary multiplication. Right here, could you come up? All right, let's try one and see how you do. How about 95 times 97? Okay, what do we do first?
You figure out how far they are from 100.
Right, and how far is 95 from 100? 5. And how far is 97?
3.
3. Now what do we do?
You subtract 3 from 95.
Right, and what's 95 minus 3?
92.
Okay, so what do we do? Just write down the 92, right? Okay, now what do we do?
You multiply 3 times 5.
Right, and what's 3 times 5?
15.
So what's the answer to 97 times 95?
9,215.
Okay, very good. Is that pretty easy? All right, but now, what if the numbers were over 100? What if the numbers were real big, like, let's use 106 times 104. All right, now what do you think we'd do? How far over 100 is it, you think? Let's try that. So this is 6 over, and how far is this? 4 over 100. Now, here's how we get the answer. Same basic concept, except this time we're working over 100, so we're going to add diagonally. All right? So what's 106 plus 4? 110. And now what do we do? There you go. Multiply 6 times 4. What do you get? So what's 106 times 104? 11,024. Okay? Is that pretty easy? Let's see how you do. Come on up. No pressure, okay? Let's do 107 times 105. All right? Okay, what do I do first?
Okay, you write 7 right there.
7.
And 5.
5. Now what do we do?
And then you add 5 to 107.
Very good. What's 107 plus 5?
113. 112.
112. There you go. Okay, and now what?
You do 7 times 5.
What's 7 times 5?
35.
35. So the answer is?
11,235.
That's it. It's that easy, okay? So that's called complementary multiplication, all right? All right, next. Now I want to try box multiplication. Has anybody ever heard of that? No. All right, let's see how this works. This is real easy. This is real neat. All you do is that when you have to multiply numbers together, you make a little box like this. Now let's say we had to multiply 24 times 12. All right? Here's how it works. You put a little slash through each box. You're splitting it in half, like this, all right? Now, to get the answer to 24 times 12, you're going to multiply the corresponding numbers. Like in this box here, 4 times 1 is going to go in there. In this box here, 4 times 2 is going to go here. And then we're just going to go all the way around the box and fill it in first. So this first box, what's 4 times 1?
4.
Now, here's why it's split. This is for the ones, this is for the tens. Bottom is for the ones, top is for the tens. So if 4 times 1 is 4, do you think it would go in the top or the bottom? Bottom. So you put a little 4 right here. Now, what's 4 times 2?
8.
In top or bottom? Bottom. And how about 2 times 1?
2.
Top or bottom? Okay, and 2 times 2 is? Top or bottom? Bottom. Now, here's how you get the answer to 24 times 12. Inside this box, all you're going to do is add these numbers up diagonally. Between here and here, what's the only number? 8. So you put an 8 here. Now between this line and this line, what numbers are there? 4, and 4 is? 8. And now between this line and this line, what do you have? 2. So the answer is 288. Okay? It's called box multiplication. Let's try one with somebody else. You. Come on up. You want to try this? Okay, no pressure, right? Let's try just a little bit bigger problem. Let's do 34 times 23, okay? That's pretty easy. Now, first I got to split all the boxes, right? Yeah. Okay, now you're going to tell me where each number goes, okay? First thing we have is 4 times 2, right? What's 4 times 2? 8. 8. Now, do you think it's going to go on the top or the bottom?
Bottom.
Bottom. Okay, we got an 8 here, right? Now, what do we do next?
3 times 3.
3 times
4.
4. That's okay. Now, what's 4 times 3? 12. How do you think I might put that in there? 12. Here's how it works. I'll give you a clue. The 10s go here and the 1s go here. All right, so all you do is just like write down the number, 12. Okay, top is 10s, bottom is 1s. Now what's the next one? Is 3 times 2, right? Okay, what's 3 times 2?
6.
Top or bottom? Bottom, there you go. And now what's next? What goes in this box right here? 3 times? 3, there you go. What's 3 times 3? 9, okay. So did it go in the top or the bottom?
Bottom.
Bottom. All right, now, how do we get the answer? We're going to add them up diagonally, right? That's okay, here you go. Between this line and this line, all we have is what? What do you see in here? 2, right? Just these lines here, what do you see? 2, right? Okay, all you got is this 2. Now everybody try this one. If between this line and this line, what's 8 plus 1? 9. Plus 9 more is? 18. Here's what you have to do. You write down the 8 and you carry 1 to the next line set, okay? Now between this line and this line, what's 6 plus 1? 7. So now can you tell me what the answer is to 34 times 23?
782.
782. All right, that's how you do it. This is just real easy. This technique works really well with students that aren't that good at multiplying the other way because they lose track of their numbers. Okay, this really keeps it organized for them, makes it real easy. Let's try another one, but a little bit bigger because this works with any size set of numbers. You can multiply a 3-digit number times a 2-digit number, a 4-digit number times a 4-digit number, whatever you want. So let's try a little bit bigger box, and we'll do a 3-digit times a 2-digit. Okay, well let's have 345 times 27. All right, first we got to split all the boxes up. Okay, we got it. Now, all we're going to do is fit each box in with the corresponding numbers, right? So let's go right down the line. What's 5 times 2?
10.
How do I get that in there? 1 on top, 0 on the bottom. What's 5 times 7?
5.
How do I do it? 3 on top, 5 on bottom. 4 times 2 is?
8.
Which way? Bottom. 4 times 7 is?
28.
How do I do it?
2 on top and 8 on bottom.
Pretty easy. And 3 times 2 is?
6 on bottom.
Bottom. 3 times 7 is? 21 is like that. Now, so to get the answer to 345 times 27, what's between here and here? 5. Now what's between this line and this line? 8 and 3 and 0 is 11. I write down 1, carry 1 to the next column. Between this line and this line, what do you have? What's 1 and 8? 9. Plus 2? Plus 1? Plus 1. What do I do? Write down the 3, carry 1. What's 1, 2, and 6? 9. So what's the answer to 345 times 27? 9,315. Isn't that easy to do? Okay, all right. Okay, now, everybody's favorite, division, right? Everybody's favorite. Okay, but now in division, what I do is really reverse because I do multiplication. All right, so let me give you an example. If you ask me what 64 divided by 3 is, I don't do 64 divided by 3. I really do 3 times what will get me up to 64. All right, so it's a little bit reversed. Now let me show you what I'm doing. Let's do that example, 64 divided by 3. Now, what's 3 times 10? 30. And now, so what would 3 times 20 be? 60. So right away, I knew it was 20-something, okay? Now, just by looking at that, we know 3 times 20 is 60, right? How much do we have left? 4. So how many more times will 3 go in there? 1. So now the answer's got to be 21-something, right? So what's 21 times 3? 63. There you go, 63. How much do we have left? 1. So wouldn't the answer to this question be 21 with a remainder of 1? Yes. All right, so but see, it's not really division because doing the multiplication the way I do it, it's a lot easier for me to get the answer to this problem by reverse division or multiplication, all right? Let's try another one. Let's do 7 into 142. Okay, so it's a pretty easy problem. What do you know right away? 7 times what is 70? 10. So what's 7 times 20? 140. So now how much do you have left? 2. So the answer to this problem would be what? 20 with a remainder of 2, okay? Really what it comes down to is you got to know your multiplication. That's all I do is I do multiplication all the time. It makes division an awful lot easier, okay? Everybody think they can do it? Yes. All right, let's see. Who hasn't been up? Right here. Can you come up? We won't try a hard one. We'll try a pretty easy one with you. Let's see. How about 6 into 129? Okay? Now, go ahead and talk to me. What do you think you're doing there?
Okay, 6 goes into 12 2 times.
Right.
So it would go into 120.
2 with a 0. You got
20
it. 20.
times.
Sorry. So now what's 6 times 20?
120.
Okay, so we know the answer is 20-something, right?
Yeah.
Okay, now how much do we have left?
9.
9. How many times do you think 6 will go into that?
Once.
So now we got 21, right?
Yeah.
Okay, how much do we have left?
Remainder 3.
Remainder 3. So what's 129 divided by 6?
21 remainder 3.
Very good. Way to go. 21 remainder 3. But what if the two numbers are the same? It's called squaring a number. All right, for example, 6 squared, which means 6 to the second power, or 6 times 6. What's that? 36. That all meant the same thing. So 7 squared means 7 times 7, or 49. How about 9 squared? 9 times 9 is? 81. What about 96 squared? 96 times 96. Okay, now here's how you do that. Okay, 96 squared. Here's how you get the answer. How far is 96 from 100? 4. So what you do is you write a little -4 underneath there. What's 96 minus 4? 92. You write down the 92. And now this number here, this 4, all we do is square that. What's 4 times 4? 16. And bring it down, and that's the answer, 9,216. Okay? It's a lot quicker. You don't have to do all the multiplication. So let's try another one. Let's try 95 squared. No, I don't want to try this. Let's hit somebody else. How about you? Come on up. Okay? Let's see how you do. What do I do if I want to figure out 95 times 95?
You see how far away it is from 100.
Okay, how far is it from 100?
5.
And what do I do?
Put the 5 right here.
Okay,
Minus 5.
-5. Right now, what do you get?
93.
95 minus 5 is?
93. Or no,
Close.
90.
Close. There you go, 90. That's all right. Okay, and now what do we do?
You put a little 2 up there.
Right, the square. And what's 5 times 5?
25.
So what's the answer to 95 times 95?
9,025.
That's good. All right. We'll work on the subtraction part, okay? All right. Now, that's if it's under 100, but let's try it over 100 and see if it works. We already got too much here. Okay. Let's try 106 times 106. Okay, that'd be 106 squared. Okay, here's how we do this. How far over 100 is that? 6. So what we're going to do is add 6. Instead of subtract, we're going to add now. So what's 106 plus 6? 112. We write that down. And now what's 6 times 6? So what's the answer to 106 times 106? 11,236. Is that pretty easy? Okay, let's have, right back there. Can you come up? Yeah, we're going to see how you do, okay? Let's try a real big one, too. Let's try 109 squared. What's 109 times 109?
109 times 109.
Come on over here so you can see it and work it out. Okay, now what do you do first?
Add 9.
Add 9, okay, very good. And what do you get? What's 109 plus 9?
118.
Right, 118. Okay, now what do we do?
Square the 9.
Square 9, what's 9 times 9?
81.
So what's the answer to 109 times 109?
1,881.
Very good. See, she's quick. Okay, now that's squaring if the number is the same. But now if the numbers are the same, but if it also ends in a 5, there's even an easier way to do it. Let's say you have to multiply a number like 35. 35 times 35, okay? Here's even a quicker way. Whenever this last digit in the answer is 5, the answer will always end in 25. All right, that's a given. Now here's how you get the first part of this answer. What's the first number in 35?
3.
And what's one more than 3?
4.
So what's 3 times 4?
12.
So the answer to 35 squared is 1225. All right, let's try another one. 65 squared. All right. What's it always going to end in?
25.
So those are the last two. Now what do we look at? 6, and one more than that is?
7.
So what's 6 times 7? 42. So the answer is 4225. 4,225. Is that easy? All right, let's see. Who thinks they could do this in their head? Nobody yet? All right. Well, let's try one and see how you do. Let's see. Who's real? Okay, you could try this. Let's see if you can do 75 squared. 75 times 75. What do you know?
You take, it'll end up in 25.
It'll end in 25. And now what do we do?
One number higher than 7.
Is?
8.
And now what's 7 times 8?
54.
Close.
56.
You got it. There you go, 56. So the answer is 5625, 5,625. Now, remember earlier we did 95 squared, but we did it like how far it was from 100 and stuff? So if we did 95 squared, what do we know it ends in? 25. What's the first digit? 9. Now what's one more than 9?
10.
So what's 9 times 10? 90. So what's the answer to 95 times 95? 9025, 9,025. That's how that works. Okay, and it works for real big numbers too. Like if you had to multiply 625 times 625, you just do the same thing. Add 1 to 62, and it works real easy. All right. Let's see. Squaring, multiplying, adding. Let's try something a little bit harder. Remember we did the cube root? Okay, how many think they could extract the cube root out of a 6-digit number? Not yet, huh? Okay, I'm going to show you a little trick on how you can do this. What is 1 to the 3rd power? Does anybody know?
1.
This means 1 times 1 times 1. It's 1, right? Okay. How about 2 times 2 times 2? 8. And what's 3 times 3 times 3? 27. How about 4 times 4 times 4? 64. And 5 times 5 times 5 is? 125. And what's 6 times 6 times 6? Okay, 216. I guess I'll start doing these, huh? What's 7 times 7 times 7? 343. And what's 8 times 8 times 8? 512. Sounds like calculators are rolling. And what's 9 times 9 times 9? 729. See, calculators aren't always right. Okay. Now, here's how you figure out the cube root of numbers, all right? Let me take, for example, I just picked a 2-digit number, and I multiplied it in my head 3 times, and I get the answer of 195,112. Now, here's how you would figure out what number I started with, all right? You split the number at the comma, and you draw a little line. And I'll put a little line here, so it's like a little workspace, okay? All we need to do is look at 2 things. You need to look at the last number on the right side and the whole number on the left side. And this is how you figure it out. The reason we look at this digit here, the ending digit, look at the answers of 1 through 9 cubed. Notice that this ends in a 1, this ends in 2, this ends in 3, 4, 5, 6, 7, 8, and 9. None of these end in the same digit. So if this ends in a 2, what number had to be multiplied to end in a 2? 8 cubed ends in a 2. So the back part of this answer is going to be 8. All right? Now here's how you get the first part of the answer. You look at the whole number. In this case, it's 195, right? What 2 numbers in the answer column does 195 fit? Does 195 fit between 1 and 8? How about between 64 and 125? Okay, where does it fit? Between 5 and 6 cubed. Always use the smaller of the 2. Which one's smaller? 5, so the answer is 5, 8, 58. All right, so that's how we did that. Let's try another one. What's the cube root of 12,167. What do we do first? Split it at the comma. What do we look at first?
7.
The 7. Now, what number did we cube to get a 7 at the end? 3 cubed ends in a 7, so 3 goes here. And now what do we look at? 12. Okay, where does 12 fit?
2.
Between 2 and 3, so use a smaller. So what's the answer? 23. So everybody see how that works? Let's try one more. What is the cube root of 175,616? You guys just look at it and try to figure it out. How we doing? What does it end in? Okay, it's 6, and what goes here?
5.
Right, now this ends in a 6. 6 cubed ends in a 6, so we knew that. And now 175 goes right here between these two, so the answer was 5, 6, or 56, all right? This only works for perfect cubes, but what it does is it'll help you estimate if it's not a perfect cube. Like, let's say the answer was 30,254. Well, you know that this is 27,000, right? And this is 64,000, so it'd be between 30 and 40. All right, it'll help you with your estimation skills too, but if it's an exact cube, you can get the answer just like that. Just look at the last digit and the whole number on the left, okay? Pretty easy? All right, you guys are ready for more. All right, let's try something really hard. Now, let's see. When were you born?
May 4th, 1977.
May 4th, 1977. That was on a Wednesday. Okay, let's see. When was he born?
September 11th, 1983.
That was on a Sunday. Okay, and when were you born? June 16th, 75. Monday. I need one more. How about you? When were you born?
July 24th, 1978.
July 24th, 78 was on a Monday, but now July 24th, 78. So July 24th, 1994, you'll turn 16, and that's going to be on a Sunday. And then you're going to turn 21 on July 24th, the year 1999, and that's going to be on a Saturday. That's good. And then you'll turn 65 on July 24th, the year 2043, and that's going to be on a Sunday. Okay? So you got to remember those. But now, that's just a little formula that I did in my head, but now I'm going to teach you how to do that, okay? Let's see. How do I want to explain it? There's a real easy way to get this. Here's the formula that you have to do. First off, you start with the year plus the year divided by 4 plus the day plus SV, which stands for significant value. And we're going to divide all that by 7 because there's 7 days in a week, all right? And now, just to let you know, here are the significant values. January is a 0, February is a 3, March is a 3, April is 6, May is 1, June is 4, July is 6, August is 2, September is 5, October is 0, November is 3, and December is a 5. Okay? Now, let me give you an example. Don't worry, it's really easy. You just have to see it the first time. Let's use your birthday. When were you born?
December 22nd,
December 22nd. What year?
1975.
75. Okay. Now, the first thing we do, what do we have here? The year, right? Okay, what year was she born in?
75.
So we put a 75 here. Now, this says year divided by 4. The reason we're doing this is to figure out how many leap years there are in 75 years. So can anybody divide 75 by 4? 18.75. You drop off the decimal, all right? So you just put 18. Next is the day. What day was she born on? The 22nd. So 22 goes here. Plus significant values for the month, right? Well, what month was she born in? December, which is 5. So now all we're going to do is add all these numbers up and divide it by 7. So can anybody add these numbers up? Let's use our left to right method and see how you do. 75, 18, 22, and 5. What's 70 and 10? 80 plus 20? 100. 105. 113. 115. 120. Okay, so now all we have to do is divide 120 by 7. All right, now how many times will 7 go into 120? 17, and that equals 119. And here's all you need to know. There's 1 left, right? That's all you need to know is the remainder. If the remainder here is 0, it's on a Sunday. If the remainder is a 1, it's a Monday. If the remainder is 2, it's a Tuesday. If the remainder is 3, it's a Wednesday. 4 is a Thursday. Who could guess what 5 is? Ooh, very good. How about 6? 6 is Saturday. And your navigator remainder is 7 because you get a 0 because it's divisible by 7, all right? So how many people think you could do that? Okay, let's try another one. And I'll give you the significant values, all right? So you don't have to worry about looking at this chart again. Okay, let's use a real old birthday. Who's really, really old here? Okay, when were you born?
22, 28, 34.
Wow, that is a long time ago. June 28, 34. All right. What's the first thing we did? The year. What year was he born in? 34. They didn't have calendars back then, but we'll figure it out anyway. Now, the next thing is 34 divided by 4, right? We're going to divide it by 4. How many times will 4 go into 34? 8 times. Then we add, what day was he born? 28th. And then we add what? Significant value for June is a 4. Very good. All right. How'd you remember that? All right. Now, we divide it all by what? 7 because there's 7 days in a week. So what's 34 plus 8 plus 28 plus 4? You guys should be able to do this stuff now.
74.
74, is that right? So we get 42. Very good, 74. You guys are quick. All right. So we have 74 divided by 7. What do we know right away? It'll go in how many times? 10 times. And that's 7 times 10 is 70. So how many do we have left? 4. So what day of the week was June 28th, 1934? 4 is a Thursday. Right. 0 is Sunday, 1 is Monday. So you were born on a Thursday. But now, let's figure out what he was this year and see how we do differently. June 28th, 34, so June 28th, 1991. All right, so 91 plus, what's 91 divided by 4? Anybody can get it? It's 22.75. Very good, 22. You're quick. All right, so we had 22 plus, the day is the 28th, plus the significant value of June was what? 4. And we're going to divide it by 7. So what's 91, 22, 28, and 4?
145.
Very good, 145. So we got 145 divided by 7. How many times will it go in there? 20. And that's 140. How many days do we have left? So what day was that? So this year your birthday's on a Friday. All right? Very good. You guys did great. Okay, so far today, we've had a lot of fun with math, but what I want to do is show you now a trick that you can use on your friends and family, okay? So I need you, because you were really good at subtraction. Come on up. Now, it's just a trick, all right? And I'll do it first, then I'll explain how I did it. What I need you to do is pick a 3-digit number, okay? And you're going to write it up here, and then I want you to reverse that number and write it here. So for example, you'd have 321, 123, all right? Now, after you do that, you're going to subtract them, and you're going to get a 3-digit answer, hopefully. Now, after you do that, I want you to circle the answer for everybody, and everybody look at the answer, all right? And now the whole time she does that, I'm going to have my back turned so I can't see any of the numbers that you used. And now, after you get the answer, you're just going to tell me any one of the digits. Like say, okay, Scott, the first number is whatever, or whatever like that, okay? And I'll tell you the whole answer, all right? And it's just a trick. I'll show you how I do it afterwards. So here you go. You take the pen and do it. Okay, and you guys need to check her work. Make sure she gets the right answer, okay? Let's see. I can't tell what she's writing up there, but I'm... Okay. No, I can't tell. Are you doing it right?
Yeah.
You subtracting right? Everybody checking her answer? Okay. All right, now you got an answer?
Yep.
All right, so now tell me, like, first or last digit?
Scott, the last number is 7.
Okay, so the answer is 297. Yeah. All right. Okay. No, you did good. All right. But now here's how the trick works. Anytime you take a 3-digit number and reverse it, and you get the 3-digit answer, there's a key. The answer will always have a 9 in the middle. Always has a 9. And the other 2 numbers add up to 9. So in this case, 2 and 7 is 9, right? So if I said to you guys, 3 is the first number, what would the answer be? 396, right? So try one more. What is, okay, the first number, no, the last number is 2. What's the answer? 792. Real good. All right, now, one thing real quick. Remember at the beginning, I asked you guys if anybody could do mental math in your head and not too many people responded? Okay, now all we did here was did everybody do this? We just added up a bunch of 3-digit numbers in our head, and we multiplied 2 and 3-digit numbers in our head, and we squared 2-digit numbers in our head and 3-digit numbers in our head, and then we were extracting cube roots out of 6-digit numbers, and then we did birthdays and out of the calendar and stuff. And everybody here basically caught on, but what you need to do is practice. All right, you've got to really practice. If you start adding up columns and numbers, you'll see how useful it is in everyday life. Like you go to the grocery store, you have your checkbooks, not you guys yet, I hope you don't have your checkbook, but if you have checkbooks in the future, you have to be able to add and subtract real quickly, all right? It'll come into use in everyday life, and also with the multiplication and all the rest of this stuff, it'll help you with anything you do in math. But more importantly, what I really want to point out to everybody here is, before I asked you and you said you couldn't do the mental math, and now you can, right? With just a little bit of practice and a little bit of imagination and creativity involved. Now, what else did you always tell yourself that you could never do, but you probably could if you tried just a little bit harder and looked at it a little bit differently than how you have in the past? So that's the key issue. Our program is called Motivation Through Mathematics because math is a great tool to build your self-esteem and your self-confidence. When you see that you can add up columns and numbers when you thought you never could, it should make you stop and think, you know, boy, I wonder what else I could do if I tried just a little bit harder, all right? And that's the key message. So math is important. We need to use it in our everyday life because it'll make a significant difference in the way you live. But also remember, never limit yourself, okay? And math is just one key thing. You've got a lot of other things you have to do in your life. Make sure you give 100%, okay? You guys did really good. Thanks a lot for coming. Good luck with your program. And you've got your video, so take it. And when you want to practice, just pop it back in. You can go through the examples as slow as you like, and make sure you understand each thing before you go on and on. Good luck becoming a human calculator.